Okay, let's dive into this. Welcome to today's explainer. We're looking at Day 5, LLM fundamentals. Now, today is all about pulling back the curtain on large language models to see the actual engine running under the hood. Our overarching goal here is to move past all that intimidating jargon and truly master how these core elements operate together. We're going to turn these concepts into clear, actionable knowledge. So let's get into it. So here's our game plan for today. First, the LLM toolkit unlocked. Then, breaking down the language. Number 3, memory and AI creativity. Fourth, upgrading your AI's knowledge. And we'll wrap it all up with building the Q&A bot. Now don't worry if this sounds like a lot, we're going to systematically conquer all of this dense vocabulary together before we hit that final project. Starting off with Section 1, the LLM toolkit unlocked, preparing for our final project. All right, so we've got 6 essential building blocks today: tokens, context window, temperature, embeddings, fine-tuning, and RAG. Now, I really don't want you to view these as just a bunch of boring, highly technical definitions. Instead, think of them as an accessible, essential toolkit. Literally, just as a carpenter needs a hammer, a saw, and a tape measure to build a house, we absolutely need these specific tools to construct our ultimate goal, a fully functional AI Q&A bot. Moving on to Section 2, breaking down the language from words to math. Let's look at the logic of how an AI first begins to ingest human text. Before an AI can answer any question you throw at it, it has to break your prompt down into digestible pieces. It doesn't read a sentence the way you and I do. It uses tokens. Tokens are the fundamental building blocks, basically the atoms of language that a large language model processes. When you type something in, the very first thing the system does is chop that text up into these mathematical pieces. It's slicing words, parts of words, even spaces into a format it can actually compute. Without tokens, the AI is literally blind to your text.
Now, what's really interesting about this slide is the math behind a token, because a single token doesn't perfectly equal a single word. As a general rule of thumb, one token is fractionally equal to about 0.75 words or 3/4 of a standard word. So a simple word like apple might just be one token, but a longer one, like unbelievable, might get chopped into 2 or 3 separate tokens. And grasping this 3/4 ratio is absolutely crucial, because later, when we talk about the limits of an AI's brain power, those limits are measured in tokens, not words.
Okay, so once the text is chopped up, the AI needs to figure out what those tokens actually mean. This is where embeddings come in. Think of embeddings as a multidimensional mathematical map of meaning that groups similar concepts together. It's like a giant 3D map where words with similar meanings are plotted physically close to each other. So the token for dog and the token for puppy are plotted right next to each other on this map, while submarine is way off in a totally different corner. This is exactly how the AI understands context. It doesn't know what a dog is in real life, but mathematically, it knows exactly where it lives relative to everything else in human language. Which brings us to Section 3, memory and AI creativity, controlling the brain. Because once the AI understands the words via embeddings, well, we've got to manage how it remembers and reacts to them. Just like us, an AI can't remember an infinite amount of information at once. It has a strict boundary, and we call this the context window. This is the AI's short-term memory capacity limit for a single interaction. So, linking back to earlier, the context window represents exactly how much tokenized text the AI can hold in its head at one time. If you feed it a massive textbook that blows past its context window limit, it's going to completely forget the beginning of the book by the time it reads the end. It's a hard, strict limit on short-term memory for any given task. Now, once we know its memory capacity, we actually get to dictate how it responds. We do this by adjusting the temperature. Temperature is simply the specific setting that controls the randomness, predictability, and creativity of the AI's generated response. I love thinking of this as a simple creativity dial. It's a dial you have total control over, and you just adjust it based entirely on whatever your specific project needs. And this brilliantly illustrates how tweaking that temperature bar changes the AI's answers from highly predictable to highly creative. On the left side, we have low temperature. Turn that dial down to near 0, and the AI becomes highly factual, focused, and predictable. It gives the most statistically likely answer every single time, perfect for coding or data analysis. But turn the dial up to high temperature, and the AI starts taking risks. The output becomes highly creative and a bit more random. That's what you want for writing a poem or brainstorming marketing slogans. It's the exact same model, just a completely different temperature setting. Moving on, Section 4, upgrading your AI's knowledge beyond the base model. Now that the AI understands language and has memory, We need to solve the limitation of teaching it specific or private data. So think about this for a second. How do we teach the AI new facts it wasn't originally trained on? Say you want it to answer questions about some private HR policies your company wrote yesterday. The base model has zero idea those documents exist. So how do we fix that limitation? Well, this introduces the final two power tools from our Day 5 list. There are two main ways to handle this, and understanding the difference between them is a real game changer. The first is fine-tuning. This is updating the AI's internal brain by retraining it. You're permanently altering that mathematical structure, those embeddings we talked about, by feeding it thousands of new examples. The second method is RAG. RAG is essentially giving the AI an external open book to read. Instead of rewiring its brain permanently, you just take your private HR document, slide it into the AI's context window, and say, hey, use this specific document to answer my question. RAG retrieves external information to temporarily boost the context window without altering the model itself. It is incredibly fast, efficient, and popular. All right, section 5, building the Q&A bot, assembling the pieces. It is time to assemble all this newfound vocabulary with high energy to finally complete our Day 5 project. Let's move to and see how this builds a complete step-by-step workflow. Step 1, we ingest targeted data via RAG. Basically, we hand the AI the open book of information. Step 2, the AI processes that information by breaking it down into tokens, holding it all securely within its short-term memory, the context window. Step 3, we adjust the temperature for the perfect answer. Maybe we dial it down low so the bot gives us strict, factual answers based only on our RAG data. Every single term we define today naturally connects together to run this AI Q&A bot. It is just such a beautifully logical system. By truly grasping how these core elements interact, you aren't just memorizing definitions, you are learning how to engineer outcomes. These fundamentals empower you to build incredible things far beyond today's lesson. You now hold the keys to the LLM engine. So, with your toolkit unlocked, what will your AI build next? Thanks for joining me for this explainer, and I'll see you in the next one.